we have, how do you find excess reactant? To find excess reactant. So with this, it is a little bit tricky because the way excess reactant is based on the mole ratio. So there's two things here. It's not the mass, and it's not just how many moles each has. It's based on the mole ratio. For example, if I had a, so based on mole ratio, if I had A plus 2B turns into A B2, okay? For every mole I had of A, I needed 2 moles of B. So when I say based on the mole ratio here, I mean that this has to be kept 1 to 2. So if somebody said that, oh, I was given a 0.6 moles of A and 0.8 moles of B, yes, B has more moles present, but it wouldn't be excess reactant. We want to see if it still has that ratio of 1 to 2. So I'm going to actually highlight that because that's very important. So the way we figure out what the ratio is that we want to get one of them to 1, preferably the smaller one, so we can kind of mimic what's going on with the ratio that's actually from the formula. And if we see here, we divide both sides by 0.6, we get 1A, but the B here is going to be 0.8 divided by 0.6, and we get like 1.3, or kind of like 4/3. Point being though is that, as we see here, we have 1A, but it's not the same anymore. It's not 2. It's 4/3, which is less than 2. So because, as you see here, the mole ratio isn't the same, right? The side that's slacking here, that's not giving up the amount of moles that it needs, is a B side, because B should be giving 2 moles for every 1 mole of A. So in this case, even though we had quote-unquote more moles of B, B would be the limiting reactant and A would be the excess, because the A would be what's left over at the end of the day, because all it could really react here would be pretty much what half of 4/3 is. The reason why I say that is because that's the only way you can get that 1 to 2 ratio. So we actually only use up 2/3 of A for that 4/3 of B, leaving you with 1/3 of A left of moles. So that is how A becomes the excess. So in summary, what I'm saying here, to find excess reactant, it's not just looking at the moles, and it's definitely not looking at the mass. You want to be able to look at the mole ratio, and the only way to really find out if it's excess is by comparing it to the original formula. So sometimes you either are given the formula or you have to construct it yourself. Either way, you have to refer to that in order to be able to find out what your excess reactance is because you're comparing the mole ratios. So with that being said, they actually have a more concrete example here. And as they said, they usually start by giving us the grams. If 6.3 grams of sulfur is reacted with 10 grams of oxygen, which will be the excess reactant? So as they see here, they have 6.3 grams of sulfur, and in order for, let me just check here, they're saying that in order for 6.3 grams of sulfur to react completely, they first found out how many moles were in that sulfur, hence the first step here, and then they converted the moles of sulfur to the moles of oxygen. Then they converted that back to the grams of oxygen, and they discovered that they needed 8.98 grams of oxygen to react completely with 6.3 grams of sulfur. But we're starting with 10 grams of oxygen. So if only 8.98 was used, that means that oxygen would be the excess reactant in this case. And just to be able to visualize that, because you want to see like what the mole ratio is here, we have 2 sulfur for every 3 oxygen. So the ratio here is 2 to 3. The sulfur given was 6.3 grams, and using the numbers here, so 6.3 divided by 32.07, we get around 0.196 of sulfur, okay? And in the oxygen, we have 10 grams, and it's 32 grams because there's 2 oxygens there. So 10 divided by 32, we get 0.3125 grams. And as we said, we divide by the lowest number to see at least what it is. And in this case, after we divide by the lowest number, we'll multiply by 2 to kind of compare with the original mole ratio here. So with that being said, we have 0.196 divided by itself times 2, and we get 2. And then now 0.3125, divide that by the 0.196, and then multiply that by 2, because that's how we got the 2 here, and we get 3.18. So as you can see here, they're not the same in terms of the mole ratio, and this 3.18 is greater than the 3 that's given on the other side. So with that being said, this would be your excess because it's not putting in more than it needs to compared to the original equation, and we would have here, as you will see, 0.18 moles, well, 0.18%, if that makes sense, because we have to convert it back to that 0.3125, but we would have a leftover amount of oxygen present in the in this reaction here. So that's what I mean here by mole ratios. So it's always important just to be able to break it down like that. Overall, this is correct. And now let's move on to question number 3.